Hey guys, we have our quest tomorrow, second quest for this chapter, and it's all the systems of equations stuff. If you do not have Mrs. Andrews, then we're still reviewing some of the same material, but you may have had your some of this material may have already been tested for you. I rearranged my curriculum for Chapter 3 a little bit differently. Okay, so the first and second problem, I'm going to blow these up a little bit, one at a time. Okay. So this is an x, this is a y. So what we're doing is subbing in. So 2 times x is -1. Plus the y is 5, and we want to know, is it equal to 3 or not? Okay, guys, some of you are not good with your positive and negative numbers, so I'm going to encourage you to use a calculator, because if you know how to do the problem correctly, but you don't add and subtract very well, then you will get the wrong answer by accident. Oh, that was too much erasing. Okay, I just wanted to make that look more like a 3. Okay, so that does equal 3. That matches, so yes. Okay, it worked in the first equation, but it has to work in both. So I'm going to come over here and sub in again. 3 times -1 minus 2 times 5. And I want to know, does it equal -13? Well, 3 times -1 minus 2 times 5, -3 minus 10 is -13. Okay, so that's a yes. All right, now you found all the evidence to support your answer, but you have not answered the question. The question is it a solution? So now you're going to write down your conclusion. Since you have both yeses, don't use the word it. Write the actual coordinates. -1, 5 is the solution. Okay, and let's look at the second problem. Same thing. This is an x, that's a y. So we're just subbing in to see if it works. Okay, so I subbed in 3 for x and 4 for y. -12 plus 4 is -8. So that's a yes. Okay, so let me just use color to show you what I'm doing here. Okay, so 4 subs in. Okay, we're going to do the same thing over here. 2 times 3 plus 4, and we want to know if it equals 9. So subbing in the 3 for the x and the 4 for the y. Okay, 6 plus 4 is actually 10. They do not match. That's no. So this was yes, but this one's no. 3, 4 is not the solution. Okay, now just as an FYI, let's say I had answered this first as a no. I wouldn't need to bother doing the second one because it wouldn't come out, wouldn't matter whether it was a yes or no. As soon as you have one no, it's not a solution. Okay. Now we're solving the system by graphing. So we got to remember how to do that, okay? So M, remember, stands for our slope. Our slope is the first number in the problem. It's usually a fraction, and if it's not a fraction, we make it a fraction. So it's 2/3. The fact that it's positive means go up 2, and we always move to the right. and I start on 0, -3, which is my y-intercept. So I'll put a dot here on the -3, and then I will go up 2 and 1, 2, 3 to the right, up 2, 1, 2, 3 to the right, down 2, 1, 2, 3 to the left. Very important to draw as many dots as you can. And don't forget to label y equals 2/3 x minus 3. Then our second equation. This is our slope, -1/3. Now, notice it does not say anything after the x in terms of plus or minus. Okay, well, there's an invisible plus 0 there. That's because if we add 0 to the equation, it doesn't change anything, so we usually just make that invisible. We don't see it. We don't need it. Okay, so, but it makes my y-intercept the origin. So I'll put a dot there. And then negative means go down 1 and still to the right. Down 1 and 1, 2, 3 to the right. Down 1, 1, 2, 3 to the right. Okay, continuing the pattern in both directions. Labeling y equals -1/3 x. Okay, so we've done all of our evidence for our solution, but we have not said what our solution is. Our solution is where the two lines cross, and it's the coordinates of it, which is 3, -1. And guys, super important. You cannot reverse the numbers. It's wrong if you write the -1 first and then the 3, because -1, 3 is up here, and that's not where they cross. Okay, so because there are two axes with the same numbers on them, the order helps us know, well, which 3 are we talking about, the x3 or the y3? Well, if we wrote it first, it's the x3 and the y -1, and it's always xy order. Okay. Next one. All right, so we have a slope here that is not a fraction. So we're going to make it into a fraction by putting it over 1. So -2 over 1, that means down 2 and 1 to the right, and we're starting on 0, 1. Down 2, 1 to the right, down 2, 1 to the right, down 2, 1 to the right. I'm going to come back to the original point, up 2, 1 to the left, up 2, 1 to the left. Okay, and label y equals -2x plus 1. Okay, second equation, also not a fraction, but whoa, I'm starting to get a little alarm going off in my head saying, that's -2 also. I'm going to go down 2 and 1 to the right again. But this time I'm starting on 0, 4. Okay, 0, 4, down 2, 1 to the right, down 2, 1 to the right, down 2, 1 to the right. I'm doing the exact same slope. And if my lines have the exact same slope, but different y-intercepts, okay, so I've got the same slope, but different y-intercepts, that means my lines are going to be parallel. Okay, my lines are going to be parallel. They are never going to cross. So instead of writing numbers in here, you're going to write no solutions. I had a couple of students today tell me that the solution was 0. Now 0 is still a number, okay? And there's no crossing at 0, okay? So solutions, no solutions. That's what you write, okay? Label the line, y equals negative 2x plus 4. Some of you may be thinking, wait a minute, how did we get infinitely many solutions? That's not this problem, but how is it that would happen? That could happen. Let me see if I can get this to work. No. No. All right, I was trying to move just the blue line, but it won't let me. If I took my blue line and I shifted it, if it was the exact same equation, if they were both negative 2x plus 1, then they would be right on top of each other, and that would be infinitely many solutions. But this is no solutions because we've got parallel lines. Uh-oh. We got to solve by graphing, but I can't see on here. Let me move this down a little bit. There's no y equals mx plus b. It's not in that format right now. It's not in that format right now. So I'm not going to be able to graph it yet. What you're going to need to do is rearrange the equation. So for example, I want the 3y. It's too far to the left. It needs to be underneath the y. This minus 3x is on the wrong side of the equal. It belongs over here. 3 should be underneath the b. So we got to start using our mathematical operations to rearrange this equation. I'm going to start with the 3x. Okay? If I move this 3x to the other side, and the only way you can do that is to cancel it off the left, which means use plus to counteract the minus. Okay, then my 3y can come down and be right underneath the y. Okay, so we're starting to get into better shape here. 3 and 3x. I wrote them as an addition problem, but I can't really add them together because 3 does not have an x and this 3 does. So I'm going to leave them separate, but I'm going to be conscious of the order. I want the x term to go first and the b to go second. Then I want just y equals, and so far I still have 3y, so I'm going to divide everything by 3 and get y equals. Now, I'm reducing that fraction. I could have just divided it out to be a 1. I could have left the 1 out. But when I go to graph, I know that I need a fraction with numbers, so I'm leaving it in there. And then this 3 divided by this 3, I am going to divide out to be a whole number. Okay, this equation also is not in y equals mx plus b form. I've got to subtract, remember this is a 1x, off each side. 2y equals negative 1x, the 8 has to go underneath the b, then divide by 2, divide by 2, divide by 2, y equals, leave that as a fraction, negative 1/2 x. Divide out, 8 divided by 2 is 4. So my slope would be negative 1/2, which means down and to the right, starting on 0, 4. Okay, now that I have that done, I can graph these lines. So my blue work is telling me to start on 0, 1. Positive 1 over 1 slope means go up 1 and right 1. Up 1, right 1. Up 1, right 1, right 1, right 1. And label. Remember to label the way it was originally written. Okay, then my red work, my red line is going to start at 4. And I'm going to go down 1, 2 to the right. Down 1, 2 to the right. Down 1, 2 to the right. X plus 2y equals 8. Okay, I've done all this work, but I still have not answered the question. The solution right here, make sure you don't leave that blank tomorrow. Make sure you fill that in. 2, 3. Okay. All right, substitution method. One thing that I changed on the quest for tomorrow, but forgot to change on the review packet, is this equation. Okay, I want to make sure that I show you substitution. So I put one of them in y equals form. Okay, so if y equals negative 2x plus 19, and I have a y here, so here's a y, and y equals this stuff right here, then that's the stuff I am going to sub in. So 3x plus 3, but instead of y, I'm going to put negative 2x plus 19 in parentheses because that's what y is. And then equals 33. So my first step was to sub in. Then I'm going to distribute. So bring down 3x. It's awfully tempting to bring down this plus sign, but positive 3 times negative 2x is actually a minus 6x. So that's a sign error that I don't want you to make. Think through your signs. 3 times 19, they're both positive, so plus 57 equals 33. So that was distributing. Then I'm going to combine like terms. 3x take away 6x is a negative 3x. And then a two-step. So minus 57 and divide by negative 3. And x equals 8. So then I'm going to sub x in and find y. Okay, so you're trying to find y. You could pick either equation that you want to sub the x into, but it's honestly easier to pick the one that's already in y equals form. So negative 2 times 8 plus 19. Okay, so negative 16 plus 9 is 19, 3. So for a solution, I'd have x equals 8 and y equals 3. If I wrote that in coordinate form, it would be 8, 3. Check. 3x plus 3y equals 33. 3x plus 3y equals 33. Well, x was 8, y was 3. 24 plus 9 is 33. So I checked, they are correct. Now for the purposes of this video, I'm probably not going to do any more checks because they're time consuming. So I wanted to show it to you once, but after that I'm probably not going to show them again. You still have to do it for your homework, you still have to do it for the quest, but It's just to make the video a little bit more manageable in terms of time. Okay, the other way that we could be doing substitution is if we notice that both of these are y equals. That means we can set them equal to each other. Okay, so set equal to each other. The mx plus b's. Okay, take the y's out. All right. Then you've got variables on both sides. Here's the equal sign. There's a 4x on this side and a 6x on this side. So my strategy is always to go for the smaller x. Cancel that one. You have less negatives that way. Add 7 to both sides. We're down to a 2-step. Okay, so after variables on both sides, we did a 2-step. And x equals 8. Then we're going to pick an equation. They're both in y equals form, so it kind of doesn't matter which one you pick. 4 times 8 plus 9. So I subbed in the 8 for the x. (32 plus 9 is 41. So my solution is x equals 8, y equals 41, and if you write it in coordinate form, 841. All right, elimination method. What we're looking for is that either both x coefficients or both y coefficients are the same number but opposite signs. And in one of your questions, this one, you're going to get lucky and you're going to notice that it's already set up this way. These are both 2's. One's a minus 2, one's a plus 2. So 2x minus 4x is negative 2x equals, now this is kind of an unusual situation. I've got negative 10 plus 10, and that makes a 0. Okay, it could cross out just like we do with the 2y's, but if we crossed it out and we didn't write anything here, we wouldn't have any numbers to finish the equation with. So divide both sides by negative 2, and x equals 0. Well, Mrs. Andrews, shouldn't it be negative 0? Well, 0 is its own thing. It's neither positive nor negative. Okay, so it's just 0 is just 0. Okay, then we're going to take our 0 and sub it in. So 2 times 0 minus 2y equals negative 10. Well, 2 times 0 is 0 equals negative 10. Normally at this point it would be a basic 2-step, but since this is a 0, we don't really need a 0. 0 wouldn't change anything, so I'm just going to divide both sides by negative 2, and y equals 5. So my solution is x equals 0 and y equals 5, or 0, 5 in parentheses. Again, you're going to be responsible for checking. Multiplication and then elimination. Okay, so in this problem, 3 and 2, they're not the same number and they're both positive. Well, all right, let's try the y's. There's an imaginary 1 here. Okay, 4 and 1, also not the same number, and they're both pluses. So I got to make them the same number. Well, the easiest thing, it's not the only way to do it, but the easiest way to do it would be to take the second equation and multiply by negative 4, because that would make this middle term negative 4y. And then it could cancel out with the plus 4y in the first one. So that would be negative 8x minus 4y equals positive 12. Now the equation I'm working with is all the way up at the top, so I want to bring it down and put it underneath. And then I would get negative 5x. Those would cancel, equals 5. Divide both sides by negative 5, and x equals negative 1. Okay, now that we have x equals negative 1, just like we've been doing, we're going to sub in. So 3x plus 4y equals negative 7. But instead of x, we're going to put negative 1. Negative 3 plus 4y. And we got a basic two-step. Add 3 to both sides. Divide by 4. And y equals negative 1. Oh, come back. Okay, so our solution would be x equals negative 1, y equals negative 1, and we can write it in coordinate pair as negative 1, negative 1. Okay, word problem, the dreaded word problem. It's only one. Okay, John bought a shirt and a tie from the store for $20. That week, the same store sold 40 shirts and 15 ties for $500. How much does each shirt and tie cost? Okay, so what are we trying to find out? We're trying to find out the cost of a shirt. And we're trying to find out the cost of a tie. Let's go back and reread the questions because the words say the equations in word forms. John bought one shirt and one tie for $20. That's one of my equations. My other equation, that week the same store sold 40 shirts and 15 ties for $500. 40 shirts and 15 ties for $500. Now somebody in one of my classes said, well, they're $10 a piece. You know, one shirt, one tie, $10 for each. Well, not necessarily. Okay, the shirts could be $8 and the ties could be $12. Okay, all we know is that the two numbers add to 20. There's lots of numbers that add up to 20. It doesn't have to be 10 and 10. Okay, the way these are set up, something variable plus something variable equals a number. This means that we're going to do elimination as our strategy. In other words, I either want to be able to cross out my S's or cross out my T's. And I can't do that right now because I either have 1 in 40 or 1 in 15 and no negatives. Well, the great thing about ones is that I can turn them easily into whatever number I want. So I'm going to choose to make the 1t into a 15t. But I also need it to be negative because this t down here is positive. So I'm going to multiply negative 15 by everything. Negative 15s minus 15t equals negative 300. Okay? And I get 25s. Those cross off. That was the point. Equals 200. Okay, so the cost of a shirt is $8. So now we got to find the cost of the tie. Okay, Well, one shirt is $8 plus one tie equals 20. So a tie costs $12. All right, checking it. So 40 times $8 for a shirt plus 15 times $12 for a tie. And we want to see if that equals 500. So that's 320. 15 times 12 is 180. So yes, that makes 500. Okay. Okay, number 11. It says solve using any method you choose. If you don't choose graphing, ignore the graph. Okay, so number 11 looks just like number 5. Same number, different numbers, but same idea. Okay, if I want to, I can solve number 11 by graphing. Add 2x to both sides. Y equals 2x minus 5, so my slope is 2 over 1 up to right 1. And my y-intercept equals 0, negative 5. So 0, negative 5 up to right 1. And then I do the same to this equation, negative 4x. Well, shoot, these come out the same. And I get infinitely many solutions. That's okay. Your quiz one won't necessarily do that. Okay? If I wanted to, I want to put that back. Let me put this back for a second. Let's say I wanted to solve by setting the two y equals next to each other. I could do that. 2x minus 5 equals 2x minus 5, and do variables on both sides. Now in this case, guys, infinitely many solutions, my two sides are equal, so I can't really follow through with that. But pretend that you could. Then you'd be solving this just like this question, where my two y equals mx plus b's are next to each other. So you could do that. I could do substitution. 4x minus 2, and then sub this in, 2x minus 5 equals 10. I could do that and then distribute and so forth. Or, to be honest, what I would definitely do if this were my quiz and I was the one doing it, I'd stack these. Remember that that's a 1. I would multiply the top equation by 2. Oh. Take this line away. So negative 4x plus 2y, negative 10. Those would cancel. Actually, because this is infinitely many equations, or infinitely many solutions, everything cancels. But my point is, the last problem, it's possible to use any of your solution methods. Probably what most of you will choose is elimination, because that's what I would pick. Okay? If you don't choose solve by graphing, you may ignore the graph. You don't have to pay any attention or use the graph at all unless you are solving by graphing. Good luck on the quest, and I'll see you next time.